Hello, welcome back to the channel. This is the basics of Diag, and today we are looking at a 2008 Suzuki Swift with the 1.3 diesel engine in it. I'm pretty sure it's a Vauxhall engine, and we looked at this about 6 months ago. It had a starting issue. We did some glow plugs and a glow plug module. If you want to see that video, it's up here. But today, we've got another issue. The vehicle owner is concerned about a lack of power. There's a spanner with car warning light coming on, and yeah, this is the warning light that's coming on. Now, the owner of this vehicle says that it usually happens in about third gear when the engine speed is kind of about 3,000 RPM. The light will come on, and then if you sort of back off the throttle, the light goes out, and then it's kind of in limp mode, and yeah, the light won't come on again until the key is turned off, the ignition's turned off, the engine's just restarted, it's got full power again, and then the same again. Third gear, 3,000 RPM, the warning will come on. So we will get the scanner hooked up, see if there's any fault codes, maybe clear them, and then we'll go for a spin and make sure we can recreate this fault. The owner says it happens, they can get it to happen every time they drive, which is good news for us. Being able to consistently recreate a fault is a massive help when it comes to Diag. So let's see what codes we've got. Right, so we've got the trusty snap-on Modus Ultra. Let's do a full code scan. Let's just reposition it so there's less glare on the screen. Now, if you remember, if you watched the last video with this vehicle, we had obviously a glow plug signal fault, and we had a P0400 fault, EGR flow. And obviously that hasn't returned this time. We've got a map sensor circuit high input fault. So whether there is an issue with that EGR, or whether that was a code from a previous life, you know, previous repair has been done, codes haven't been cleared, or whether, I don't know, whether that is going to rear its head at some point in the future. Best practice is obviously to just document the codes that we have. We're not going to go chasing an EGR issue if this fault that it's got isn't sort of logging an EGR fault. If this map sensor fault comes back when it goes into limp mode and the warning comes on, we're going to be chasing this map sensor fault. We're not going to just go for an EGR fault. So just engine codes with that then. We'll see if there's any freeze frame data. I don't think there is. So that's, yeah, I wonder if EOBD has got some freeze frame data for us. So display trouble codes. No codes present. See, that's sometimes the issue with EOBD. If the EML isn't on, you usually find there won't be a fault code logged. So if you're just using a generic OBD scanner and you're getting this spanner car light warning coming on with a lack of power, but it's not triggering the EML to come on, you're going to have a hard time sort of getting a direction as to where to go. What's the data like in EOBD? So we know there's something with the map sensor. So have we got any map sensor data in EOBD? Let's have a look. Come on. So we've got intake map there. Okay, so it has got a line of data for map sensor. And let's go back to the vehicle specific. And the first thing we'll do, clear the code's P0108. So let's clear code. Oh, it says engine off, key on, but I'll do it with the engine on and see what happens. Codes. No codes present. Now let's go to scan data. And I want to see, do I want some data yet? I don't know. We can get some up, can't we? We'll get some up. We know we want to look at map. Probably some throttle pedal. And then we've got a bit of an input. So let's select some throttle pedal percentage. Do we want engine speed? We'll have a bit of engine speed. We'll go for some mass airflow. Where's map? Map should be before mass. Unless it's this, turbo pressure, it might be that. Right, we'll just look at that for now. And we're going to graph it. So we'll go for 4 graphs, 2 graphs I think per screen. The good thing with this is that it'll give you a minimum and a maximum value. So it said it thought the map sensor input was high. So where are we at? So the pressure's 99 kPa, which is about right, atmospheric, and I've just given it a blip of throttle there. Yeah, so 99, 100 kPa is about atmospheric pressure, 1 bar. And this is only going to have a small turbo, I would think, little 1.3, so I can't see this pressure going much more above 2 bar. If we had some sort of genuine data, we would be able to find out exactly the max pressure this turbo provides. We don't have access to that, or I don't have access to that, so we're going to go for a spin now. See if we can get this fault to happen. When it does, hopefully there's something in this data that's going to point us in a particular direction. Alright, second gear. That was 3,500. Nothing happened. I think you should be able to see the lights come on the dash. Right there, and it was about 2,800 RPM, I think. And now the light's gone off again, but we have got, yeah, limited power. Okay, let's just pull over. And see. If there's anything in the scan data. Just pull over behind here. Just do. So here, boost pressure sensor, voltage down here. Obviously, it's, as I said before, this gives you the max and the minimum. So the minimum was a 1.8 bar, which is what it was at idle. Not 1.8 bar, 1.8 volts. That's volts. That's turbo pressure sensor voltage. Turbo pressure sensor voltage, yeah. So 1.8 volts is equal to 1 bar, pretty much. And then it went up to 4.7 volts, which, in my opinion, I think is too high. Usually these sensors that are sort of 5 volt reference have a working range of about 0.5 volt to 4.5 volts. And then there's that bit of headroom above 4.5 volts and below 0.5 volt, so that the ECU can detect for shorts to ground or shorts to power, or input too high, input too low.
Boost pressure got up to 2.5 bar. 2.5 bar for that little turbo. I'm not sure, you know. I'm not sure. And we can see, I think this peak was the 2nd gear pull. This was the 3rd gear pull where the light came on, and this was the pull after the light had come on and we were in limp mode. Yeah. And obviously I think that is the 4.7 volts. I'm going to try and move this blue cursor to over there, but the scanner's a bit numb and it's a bit slow to respond, so... Oh, she's going though. Come on. Do you hold it? Oh, that's too far now. Alright, let's go back. Come on. Right, we're nearly there, look. 4.5 bar. Can I zoom in some more? Zoom in ×4. Right. And move across. So yeah, 4.6 volts, 2.5 bar. That was the 2nd gear. Pull, and then yeah, voltage came down. And then this peak that's coming across now. Our cursor's here, so we're measuring the voltage at this blue line you can just about see, and pressure. And now we are on the throttle. Come on. .2 volts. .6 volts. 4.7 volts, and that was at the peak, and then it, yeah, comes back down to, oh god, let's numb this thing. Come on, you can do it. There we are, 4.7 volts. And if we look at, we could maybe look at engine speed, 2,700 RPM it reckons.
Looks like we're going to be testing power supply, ground and signal wire voltages to the map sensor. We could look at a wiring diagram just to confirm which wire's which, but I know that this 3-wire sensor, I'm assuming it's going to be a 3-wire sensor, unless there's a temperature sensor in there. Yeah, maybe we should look at wiring diagram. But yeah, if it's 3 wires, it's going to be power, ground, signal. If it's 4 wires, there's going to be a power, ground, and 2 signals, one for boost pressure and one for intake air temperature. But yeah, I'm going to just drive this back down now. We'll see if this fault happens again, and then I know I can replicate it multiple times. And then, yes, we shall look at wiring diagram and get the oscilloscope out. Fault occurred again, exactly the same time, exactly the same conditions, so that's good news. It means after we replace a part or repair a wire or whatever it might be that's causing this, we can just drive it how I've just driven it, and the fault should be gone. Let's have a look at wiring diagram. Okay, so this is our wiring diagram. This is off the Garmin app, and I think it is genuine Suzuki. If you watched the glow plug starting issue we had with this car, it's the same diagram I used for that. And our boost pressure sensor or map sensor is here, D06, 3-wire sensor. We've got obviously a power, a ground and a signal wire. So pin 2, middle pin, should be ground. Pin 1 should be a 5-volt reference, and then pin 3 is our signal wire. So I'm going to scope all 3 channels at once. We're going to go for a drive, make it fault and see whether the power and grounds are stable, and then see whether the signal wire voltage on the scope matches the signal voltage we were reading through the scan tool. If them voltages match, then we know that the wiring from the sensor to the ECU is okay, and we're likely looking at a sensor fault. What it would be nice to do with this car is to tee into the inlet manifold. The pressure sensor is in the inlet manifold on this vehicle. It would be nice to kind of tee in there with a gauge, and we could see the actual pressure in the manifold, and obviously view it against the pressure that is displayed through the scan data to see whether they match. But the best I can do is use a Manifold and apply pressure over the end of the sensor, and then see how that translates to scan data. If the pressure matches all the way through the range, we know that the sensor is likely to be okay. It's reporting the correct value back to the control unit, and yeah, the turbo is putting too much pressure into the manifold. If the Manifold and the scan data don't match up, then we know the sensor is likely at fault, because we've already checked the wiring. This is going to be the step after checking the wiring. So yeah, I'm going to get the laptop and the scope set up, and then we will go for a spin, make it fault. I'm going to pause the laptop as soon as it faults, and we'll see what happens. Right, so we're getting set up now. I've got the scope here. This is it's a Pica scope. I can't remember what model it is. The 3425.
Now this isn't an automotive oscilloscope. I think it was 200 quid, which I think for 4 channels is pretty decent, to be honest. The only thing I found is this is a differential oscilloscope. So if you look out there, every channel has to be grounded, otherwise you get some weird voltage readings, and it obviously looks like the car isn't behaving as it should be, or the scope isn't behaving as it should be. So what do we have? Channel A, the blue channel, is in the nearest pin to the front of the vehicle, and that looks like the 5-volt reference. Channel B, the red channel, is in the center pin, pin 2, which is supposed to be the signal wire. No, it's not actually, is it? That was the ground, looking at the diagram. And channel C, which I'm going to turn on right now, should be our signal wire, which if I give it a bit of a rev like that, you can see voltage increases. So the only thing to know is that the ground, obviously 0 volts could be ground, 0 volts could also be open circuit, like there's no voltage on that wire. So what I can do is I'll have to disconnect channels A and C, and then I'm just going to reverse the polarity of the leads. So I'm going to put the ground into the pin back probe on pin 2, and I'm going to move the ground wire to the positive wire, and if we get 12 volts or minus 12 volts, we know that we have a path to ground. Normally I would use a test light. I don't know where it's at. I've had a move around at work, so all my oscilloscope stuff went in a box, because we're using the one at work now, and the laptop, the computer at work, so it all went in a box. My test light was on another job, and I've been to it, I can't find it. I do have LED test lights, but the one I use, you may have seen it in a few videos, it's got a 501 bulb in the top, which puts about 300 milliamps of load on the circuit. Yeah, can't find it, so I'm just going to do this reverse polarity thing. We'll see what happens. So down here is our map sensor, boost pressure sensor, back probes in there, all 3 wires. I'm just going to disconnect. I think it'll be easier just to unplug them, but disconnect them from the scope rather than from the back probes at the sensor itself. And then I'm just going to move from negative here to positive, and we should. We'll have to make the scale bigger on here. 20 volts. And you see that's gone to minus, well, it should be about 14 volts now, shouldn't it? So that was that fucking, what was that? I think that was the air conditioning compressor kicking in there. Yeah, so that tells me that we have a path to ground. If there was no path to ground, this would still be up here at 0. So we're good to go. I'm going to put the leads back in this oscilloscope. The reason I disconnected them is because all 4 channels on this no, they can't do. I think channels A and B and channels C and D share a ground. So if you were swapping polarity and you've got another, like, yeah, if you swap the polarity whilst you've got your attached ground, it can, yeah,
it can ruin your scope, it can cause issues. So I just disconnect it all. The other scope I've got, all the channels share a ground. The 4-channel scope I have at work, all 4 channels share a ground. But it looks like I don't use this scope very much, to be honest, because of the differential. What is it? It's a differential oscilloscope, isn't it? Which is weird because they're all oscilloscopes and multimeters, not differential. Like, do you not measure the difference between your red lead and your black lead? Yeah, I don't know. It was cheap. It was 4 channels. So yeah, that's why I bought it. It didn't come with instructions, so I might just be chatting absolute garbage. Either way, it was showing me the voltages on here that I was expecting to see. We had a 5 volt on the blue channel. We had was it about 2 volts on the green channel, and we had nothing on the red channel. So yeah, connect it up, go for a drive, pause, see the results, see what is happening. Right, pause the laptop. Oh no, the spacebar's not working. So that's stopped, so I'm going to pull over and we'll just analyse these results. So we know from the data, scan data earlier, that we were getting 4.7 volts. So let's have a look and see. So if we just go back to the previous page, oh, it would be right on where it bloody skips to the next page. I'm gonna just clean the signal up a bit. Bring a cursor down. No, that's the wrong thing. No, oh, why are you doing this? So round about there is 4.7 volts. Let's zoom into this. Yeah, we can see it's about 4.8 actually. 4.8 volts. So we can see that the 5 volt reference voltage is stable at 5 volts. Ground is stable at 28-30 millivolts, or basically nothing. So it would seem that either the sensor is at fault, or we are getting too much boost in the manifold. Is that possible? Can the turbo generate more boost than it should? What would cause that to happen? Yeah, I'm not sure. Might need a bit of thinking about that. It's just a wastegate turbo. It's not variable vane, variable geometry turbo. So yeah, we will get the MIDI vac. Going to plug the scan tool back in, and we're going to pump some pressure into the sensor, and we're going to see whether the gauge on the MIDI vac matches what the scan data is showing. Now obviously at idle we knew it was about right, sort of 100 kPa or 1 bar atmospheric pressure, but maybe the sensor's slightly skewed as sort of boost comes in, and it's sort of the scale is increasing. We'll see. I'll set that test up now.
This has just gone turned into a disaster. This is the bolt that holds the map sensor in, boost pressure sensor in, around the back of here somewhere. Yeah.
It's funny because I've literally just today read on Facebook, I don't know what group it was on, somebody had posted an invoice of whatever work they've had done, asking if, you know, it was a reasonable price and whatnot. And there was a comment saying every job is, or every 20-minute job is one snap bolt away from being a 3-hour nightmare. Well, yeah. Now, I'm going to have to, oh, no, take the inlet manifold off, I think. I did the tests I was going to do anyway. I've pumped pressure into that sensor whilst monitoring the scan data, and as far as I can tell, that sensor is reporting the correct pressure. So I pump 150 kPa into the sensor. The scan tool reads 2.5 bar. Obviously it's offset by a bar, this scan data. It reads a bar, obviously when there's no pressure in there, because atmospheric pressure is a bar, whereas the gauge on that Mitivac starts at 0. But yeah, I've pumped it up at 10 kPa increments, and we are pretty much bang on right throughout the range. So this really is overboosting. So could a seized turbo, is the wastegate starting to seize? Could that cause an overboost situation? Suppose it could, couldn't it? What else could cause more pressure to be in that manifold than what there should be? Oof. Could the EGR be an issue? We had a flow fault last time around. Haven't looked at any data actually. But yeah, this, oh God, oh. Yeah, not ideal. I'm going to have to break the bad news to the vehicle owner, and then, yeah, explain how we go about at least just putting the vehicle back to how it was before I came along and touched it. So this, yeah, could be a to be continued. We will see, but yeah, thanks for watching. See you next time.